Hi guys, we have two more types of word problems that we're going to look at with systems of equations. The first type we're going to take a look at are amount value problems. So these questions, when you're looking at them, it'll give an amount of objects and there's a value attached to each of them. So this is a good example here. Ben has $12.30 in quarters and dimes. That's an important piece of information. If he has 75 coins in total, how many of them are quarters? So for these problems, I'm not going to follow the grass method as closely as I did on the last lesson. The big thing here for these types of problems is we're always going to set up a chart, and the chart really takes the place of writing the let statements and sort of starting everything off. So in this case, they're asking us to find the number of quarters. So I'm going to set up my table here. Okay, so we've got our table here. And in these amount value questions, our two rows here are going to be amount and value. And across the top, the first two columns that come next here are going to be the things that we're trying to find. So we're trying to find the number of quarters. And the other variable that we don't know is the number of dimes. And my last column is the total, because these questions involve the total number of coins or the total number of value you have in the coins. So if I'm going to plug some things in here, I don't know the amount of quarters that I have or the amount of dimes I have. So that's where my variables are going to come in. They're going to be Q and D. We know that the amount of coins that we have in total, so if we add up all the quarters and all the dimes together, there should be 75 coins in total. And then we have to talk about the value. So quarters are worth 25 cents. Dimes are worth 10 cents. And you might remember this from some of the percentage questions or the mixture questions. To figure out the value of the quarters, I'm taking the 0.25 and I'm multiplying it by Q. So this is going to be 0.25 Q. This is going to be 0.10 D. And the total value that we're given in the question is $12.30. So once we get everything in the table, then we have our two equations. So I've got Q plus D equals 75. That's equation 1. I've got 0.25Q plus 0.10D equals 1230. And that is equation 2. And as I suggested yesterday, when you have equations that have decimals in them, you really should take a step before you do anything else and get rid of those decimals. So this equation here with decimals, equation 2, has 2 decimal places. So I need to multiply each term by 100 to clear those decimal places. So if I multiply 100 times 0.25, that's 25. If I multiply 100 times 0.10, I get 10. And if I multiply 12.30 by 100, I get 1230. So there's equation 3. Now I'm going to take equation 1 and I'm going to multiply that by 10. Because if I multiply it by 10, I'm going to be able to line these guys up with the same numbers in front of the D. So that's going to be 750 when I multiply that by 10. Okay, then I've got my two equations, and I'm going to pause here. You guys can try and solve it from there, and we can compare answers here. So just like magic, there's the solution there. Now, when you get to the end and it says Q equals 32, it's important to go back up and see what Q represented. And Q represented the amount of quarters that we have. And if you look at the question, that's all they wanted to know. They didn't care how many dimes there were. They just want to know how many are quarters. So once we get to Q equals 32, we can go ahead and write our final statement. Therefore, there are 32 quarters. And that would be our final statement there. So another amount value problem here. And this one, you'll also find that it has some common parts to the mixture problems we looked at in the last lesson. So here, Jessica has a bulk food store that sells peanuts at $5 a kilogram. So the peanuts are $5 a kilogram. The pecans are $20 a kilogram. She wants 30 kilograms of a mixture that sells for $10 a kilogram. So my table is going to be set up in the same way. I'm going to have the amount and the value out to the side here. In this situation, we are looking at the peanuts and the pecans. And that's what they're asking for at the end is how many kilograms of peanuts and how many kilograms of pecans should be used. And my last column here is going to be total. So let's fill in some information here. We don't know the number of peanuts, or sorry, the kilograms, how much of the peanuts there are. So I'm going to call that X. And we'll call the amount of the pecans Y. We know that the total amount of the mixture is 30 kilograms. So 30 is going to go there. Now, we don't know the total value of the mixture. But here's what we do know. We know that it's $10 per kilogram. So if we have 30 kilograms, it's going to be 10 times 30. The value of that amount is going to be $300. Now to fill in our other two spaces here, remember that the peanuts are $5 a kilogram. The pecans are $20 a kilogram. So, like we did in the questions in the last lesson, when we have this mixture, to figure out the value, we're multiplying this value by the variable here. So it's going to be 5x. And I do the same thing for the 20 and the y. So it's going to look like that. So my two equations then are x plus y equals 30. And 5x plus 20y equals 300. Okay, so there's equation 1 and there's equation 2. Okay, I'll pause the video here while I solve this. I would encourage you guys to go ahead and try and solve this too and see if you come up with the same solution. So here's the solution that I came up with. I found y was equal to 10 and x was equal to 20. Remember to look back up above so you know which variable represents which thing. So x is the peanuts, y is the pecans. So that means she should use 20 kilograms of peanuts and 10 kilograms of pecans. All right, let's take a look at example 3, which deals with speed, distance, time problems. So for these questions, it helps to remember that distance equals speed times time. We can also rearrange that equation. So if distance is equal to speed times time, we can also write that as time equals distance over speed, and speed equals distance over time. And this last version of the formula is the one that we use quite a bit in these questions. So in this question, a riverboat took 2 hours to travel 24 kilometers down a river. So they had the current with them when they were going down the river, and then 3 hours to travel back against the current. So the distance would be the same, but then they're going against the current, and that's why it took longer. So in these questions, we're going to have a table that's got one section that's with the current, and the other one is against the current. Okay, and across the top, we need a section for speed, a section for distance, and a section for time. So this is going to be speed, distance, time. All right, and then we're going to plug some things in here. In this case, we're trying to find the speed of the boat in still water. Now the problem here is that speed is affected by the speed of the boat. Maybe we'll call that the regular speed of the boat. And the current is going to affect the speed of the boat as well. So when it's with the current, we're going to use B to represent the boat's speed and C to represent the current. So the speed of the boat when it's with the current is going to be the speed of the boat plus the speed of the current. When it's going against the current, it's going to be the speed of the boat minus the current, because that's going to slow it down. And that's really the only tricky part of the table here, because the distance is 24 kilometers in both directions, 24 there and 24 back. And then the time is 2 hours with the current and 3 hours against the current. Once we get everything plugged into the table, here's where we use the formula. So I'm going to use the formula speed equals distance over time to help write the two equations here. So in the first one with the current, speed is B plus C equals, and it's going to be distance over time. So 24 divided by 2 is going to give us 12 there for equation 1. In equation 2, B minus C equals, and in that one it's going to be 24 divided by 3, so distance divided by time is going to be 8. So there's equation 2. And with these two equations, we're going to be able to just use elimination right off the bat to solve. Okay, you guys, I'm going to pause here. You guys give it a shot and see how you do. All right, so we find the value of B. We talked about up above in the table that the speed represents, or sorry, B represents the regular speed of the boat, or the speed of the boat in still water. And if you look at the end of the question up above, it says, what is the speed of the boat in still water? So that's all we had to find was the value of B there, so we don't have to substitute it in to find out what C is equal to. Okay, one last equation or example here. This one is speed, distance, time, but it involves situations where there's a total time or distance that's given. So in this case, 395 kilometers in 6 hours. But that trip from Ski Valley to Vancouver is split into two parts. The first part of the trip is by train, and their average speed is 70 kilometers an hour. And the second part of the trip is by bus, and their average speed was 60 kilometers per hour. They want to know how long was he on the train, so we're trying to find the time. So we're going to set up our table. This time, we're taking a look at time on the train and time on the bus. Across the top, we're doing speed, distance, time again. And in this question, we're given a total. We're given a total distance there and the total time. So we need to include a row down here for total. And then we'll plug in what we know. So let's see. The speed on the train was 70 kilometers an hour. So I'm going to put 70 here for the speed of the train. The speed of the bus was 60 kilometers an hour, so that can go there. The total distance traveled is the 395. So that 395 can actually go here. And the total time is 6 hours. That's going to go here. Okay? We're trying to figure out how long he was on the train. So that's going to be one of our variables is the time on the train. We'll call that T. And that means that the other variable, even though we're not being asked to find it, is the time on the bus, which is B. So to come up with our distance expressions here, distance is equal to speed times time. So for this case here, it's going to be 70 is the speed, T is the time. So that's going to be 70T. And then in the middle there, 60B is going to go there. We never discuss the total speed. It's always average speed that we really talk about. So we don't need that there. This time to get our equations, we're going to use the vertical columns in the chart. So one of our equations is going to be 70T plus 60B equals 395, and that's equation 1. The other equation is T plus B equals 6, and that's equation 2. Okay, so we've got our two equations there. I'm going to pause it again, and you guys can try and solve that, and then compare your answers with what I have. Okay, so I solved this one. I multiplied equation 2 by 60, and then I was able to subtract the two equations. I ended up finding that T was equal to 3.5. So remember, T was the time on the train, and that's specifically what we were being asked for. They don't want to know anything about the bus, but the time on the train is 3.5 hours. All right, so we're going to practice a little bit tomorrow in class, and then we'll be reviewing for our test coming up next week.